It could turn a towering pine or oak into clean, uniform building lumber in less than an hour. A spinning steel blade more than 5 feet wide, teeth flashing, steam hissing, a boiler rumbling beneath it under explosive pressure. This machine built homes. It built railroads. It helped raise entire cities from raw wilderness. It powered expansion, industry, and ambition. But every day it ran, the men standing beside it worked next to something that could explode without warning. They fed logs into a machine that could rip wood apart in seconds, and sometimes rip them apart too. This is the story of the steam-powered sawmill, the machine that helped build America and killed its workers. The problem. In the early 1800s, cutting lumber was brutally slow and physically punishing. 2 men operated a pit saw, one standing above a log, one below in a narrow trench. They pulled the blade back and forth for hours, sometimes all day, to slice a single tree into usable boards. Sawdust rained down into the pit. Muscles burned. Productivity crawled. Water-powered mills improved the process. Where rivers flowed reliably, water wheels turned saw blades faster than any pair of arms could manage, but geography limited them. If there was no strong river, there was no mill. Meanwhile, the United States was expanding westward at a staggering pace. Settlers needed cabins. Towns needed homes, stores, churches, and courthouses. Railroads stretched across states, demanding ties and bridges by the thousands. Everything required wood. The demand for lumber was exploding, and the existing technology couldn't keep up. America didn't just need better tools. It needed a machine. The steam revolution. The solution arrived in the form of steam power. The steam engine, refined throughout the 19th century, transformed industries from transportation to manufacturing. When adapted to sawmills, it removed the limits imposed by rivers and geography. Now, mills could be built anywhere, even deep inside remote forests where trees stood thick and tall. Instead of transporting massive logs long distances, companies brought the mill directly to the timber. At the heart of these operations were enormous circular saw blades, sometimes more than 5 feet in diameter. Driven by belts and shafts connected to steam engines, they spun at astonishing speed. A single steam-powered mill could process more timber in a day than older manual crews could handle in weeks. Production skyrocketed. Forests fell faster than ever before, but the real danger wasn't the blade. It was the boiler feeding the engine. The hidden danger. Steam boilers were technological marvels and potential bombs. Inside thick iron shells, water was heated until it transformed into high-pressure steam. That steam drove pistons and rotating shafts, powering the entire mill. To operate efficiently, boilers ran under extreme pressure. If the water level inside dropped too low, the metal surfaces overheated. When fresh water suddenly touched superheated metal, it instantly converted into steam, expanding violently. The result could be catastrophic. An explosion. Boiler explosions didn't simply crack open machinery, they leveled buildings. They sent iron fragments flying like artillery shells. They scalded workers with superheated steam. Safety systems existed. Pressure gauges measured internal levels. Relief valves released excess steam. Fusible plugs were designed to melt and relieve pressure before overheating reached critical levels. But these systems required constant inspection and maintenance meant downtime. In isolated logging camps and fast-paced mills where production determined profit, downtime was expensive, so inspections were delayed, worn parts were reused, gauges clogged with sediment went unchecked. The machine had to keep running. When things failed. By the late 1800s, boiler explosions were among the deadliest industrial hazards in the United States. Newspapers regularly reported catastrophic blasts in mills, factories, and riverboats. When a steam sawmill boiler failed, the consequences were immediate and devastating. The pressure wave alone could tear apart wooden mill structures. Roofs collapsed, walls splintered, machinery twisted under force. Iron fragments from a ruptured boiler became deadly projectiles, punching through walls and bodies alike. Superheated steam engulfed workers in seconds, causing severe burns that were often fatal. Official investigations frequently blamed operator error. A worker failed to monitor water levels. A valve wasn't opened in time. But deeper causes were often systemic. Corrosion from untreated water, metal fatigue from years of stress, blocked gauges that falsely indicated safe pressure, and deferred maintenance driven by economic pressure. The machine rarely failed because of one mistake. It failed because production demands overrode caution. life inside the mill. Even when boilers didn't explode, steam sawmills were dangerous places to work. The noise was overwhelming, the constant roar of steam engines, the scream of circular blades biting into hardwood. Long-term workers often suffered permanent hearing loss. The air was thick with sawdust, which irritated lungs and contributed to chronic respiratory problems. Men handled massive logs, maneuvering them onto saw carriages. Heavy boards had to be stacked and transported quickly to maintain production flow. One slip, one misjudgment, and a worker could be crushed beneath timber weighing hundreds of pounds. Circular blades left little margin for error. A moment of distraction could mean a lost hand, arm, or worse. Despite the danger, the wages were often better than farm labor or other available jobs. In lumber towns and frontier settlements, mill work offered steady pay in a growing economy. For many families, the risk was not a choice. It was survival. The cost of progress. By the early 1900s, steam-powered sawmills were producing lumber on an unprecedented scale. Nearly every wooden structure built before 1930, homes, barns, factories, warehouses, depended on steam-powered production somewhere along the supply chain. Railroad expansion relied heavily on wooden ties and bridges. Growing cities depended on timber framing and scaffolding. Entire regions were economically tied to logging and milling. Steam power helped transform the United States into an industrial nation, but progress carried a cost. Industrial injury rates during the late 19th and early 20th centuries were staggering. Fatal accidents were common. Chronic illness from dust and noise exposure accumulated over years. Workers' compensation laws were limited or non-existent in many states. Injured laborers often relied on family support or charity. Stopping production cost money, so the machines kept running. The end of the steam era. In the 1920s and 1930s, technological shifts began to reshape industry again. Diesel engines and electric motors gradually replaced steam power in sawmills. They were more reliable. They required less constant supervision. Most importantly, they eliminated the risk of high-pressure boiler explosions. Electric systems still posed hazards. Blades could still maim, logs could still crush, but one of the most catastrophic threats disappeared. Within a few decades, steam sawmills faded into history. The forests were thinner, the cities were taller, the nation had been built, and the machine that powered that growth was quietly retired. Today, many wooden buildings from that era still stand. Silent evidence of industrial ambition. What we don't see are the men who stood beside spinning blades and pressurized boilers, the injuries that never made headlines, the explosions that shook small towns, the families changed forever. Steam sawmills helped build modern America. The machine transformed trees into cities. It built a nation, and too often it cost lives.